and the cost can be divided into different elements. The main elements are labor, material, equipment, overhead, and contingencies. And the cost is very important because it helps us with many of the initial stages of the project. Okay, and the cost can be of different types. We have the 4 types of costs here. Okay, and the last 2 are the most accurate ones. Okay, even the third one as well is the most accurate one. Okay, detailed estimate and bid estimate are almost the same, but they are from different parties. Okay, and then in terms of the expenses, you can divide them into 2 or 3 things. We have direct cost, yeah, indirect cost, and we have the contingency and the profit, something which is outside the expenses of the project. The cost can be calculated as unit cost. We have already done or covered this aspect in the type of contracts. Okay, so you can calculate the unit cost of a particular item and then multiply with the total. Okay, and the unit cost can be for the labor, for the material. Okay, and then you can add them together according to how much of each thing you are using in a activity. And it can be on the basis of production function, or which is also known as the assembly cost. Okay, so in this case you are calculating the total cost, okay, of the whole output, okay, of the whole system. Okay, so it's like lump sum basically. So and then you can divide it according to the the unit of that activity. So for example, per square meter for the wall, or per square meter for the area of the building, and so on and so forth. So then it will include all the overheads as well. And then we have the cost which is from the past data, okay, historical data. So you have similar projects being done in the past, you get their the cost, and again you calculate the rate, because your project may have a different area, may have a different size. Okay, so you go back to the old projects, but from those old projects you don't take the total cost, you take the rate of the cost. Okay, so per square meter or per day cost, something like this. Okay, and then using that you can calculate the total cost of your own project using the rate, not the total directly. But the problem with this method is you have to find out the projects which you can rely on, which are similar. Okay, and then you have the time factor as well. A project which was done 5 years ago may not give you the rate which you can directly use on your project, because there's inflation and rising in prices and new technology and so many things. So this is a thing to be considered for this type of approach. Then we have the bid-based estimating method. Okay, so in this case you ask the contractors to give their cost. Okay, and obviously contractors will include direct and indirect cost and plus a profit margin. Okay, and in this case you are relying on the contractor cost, and you will mostly take the most competitive price. Most competitive means in 99% of the cases most competitive bid means the lowest one. Okay, although it shouldn't be, the lowest price is not always the best price. Okay, the lowest price is not always the best price. So but in competitive bidding, this is what in essence it means, that we are looking for the contractor who will give us the lowest cost. Okay, in this case it is very close to the market prices. Okay, it gives you a true estimate of the market prices, because it's given by the contractor. So he is the guy who has an idea about the material, he is the guy who has an idea about the labor, because he is using these things day in day out on all the other projects. So when this guy says cement is this much, he already has a fair idea about it. Okay, so so in this case the problem is the competition itself. Okay, the competition itself is the problem, and you are relying on the contractor's bid. So if a contractor says I can do this thing in 50,000 BD, and this one is the lowest one, you are basically relying on what data he has used from the market itself. Okay, and he may have manipulated the data because he wanted to get the contract. He wanted to be the most competitive one. So this is a problem in this approach. So the contractor, as you can see, may have broken down the price into these items. These are just total price, but the contractor is not calculating the price like this. When he is calculating, he is doing more detailed estimates. So this is just like the tip of the iceberg. Okay, just looking at the total one, but labor and material, he should have, or he must have done some calculations to come up with this 400,000. Okay, overheads, yes, overheads can be an estimated value. Okay, that normally we keep this much overheads for a project of this type. Same thing with the profit margin as well. Okay, so you can see that both of these things are not major components. Okay, they are not major components, they are smaller components. So in this case we can, even if they are not so accurate, we can work with them. Okay, so this is something which we have done earlier as well in the cost estimation course. Okay, so for example, we are constructing this concrete arch. Okay, like a circular structure arch. Okay, and it will be built at the entrance of some city, I don't know. Okay, we don't have them here like that, the entrance, but in old European cities you will find these arches. Even in Pakistan you have some old doors, some entrances. Okay, anyways, so this arch will be mounted on two columns, and size of the arch is given. Okay, the width is 29 meters and the height is 10 meters. Okay, so this is the width and this is the height. Okay, and we are using steel which is how much, 16 millimeter dia. Okay, so first thing is we should produce the WBS of the project, and then we can move on for the cost breakdown structure. Okay, so our WBS will look something like this. Okay, so many of you were asking me at the start of the course, or when you were selecting the topics for your term projects, okay, that how can we create WBS, or how can we do the project when we have not finished the design. Okay, so this is, you can see there is no specific item which requires any size or something. Okay, these are just general items which you can know from the type of project. Okay, so the project starts with initiation and planning. You do the feasibility study of the site. Okay, assessment of the site, how is the weather condition, how much space you have. Okay, and these type of things. Then you go for the design. The design will be architectural design, structural design, and then the design must be approved from the local authorities. And here you can see initiation and planning are merged. Okay, so that's why the approval is at the same stage. So approval is after the design. There was an activity in one of the questions in the exam. So just to clarify, approval of the authorities is after the design is prepared and authorities approve the design. Okay, the final construction is supposed to be approved by the client, okay, or the consultant, that it is according to the design. Okay, and the authorities, they come and check if you did not do any violation. That's it, but they don't give the approval. Okay, then you take the permits and any legal documents which you need, again from the authorities. Okay, so after the approval you can get these permits. Okay, they can be permits for installation of water pipelines, electricity lines, and so on and so forth. And legal compliance means check who is the owner, and the tender documents and everything. Then you prepare the site, clearing, leveling. Okay, if there are utilities there, you have to relocate them till the project is going on. Once the groundwork is complete, you can put the utilities back. Okay, if there's a problem like this, then You have foundation construction. I believe all of you did very well in the most of you selected these activities for the dependencies in the project. So this is very straightforward. You have the foundation excavation, then you have the reinforcement and formwork and the concrete pouring, and after pouring you need to do the curing. Then you have the column, same activities, reinforcement, pouring, curing, and then you have the surface finishing as well. So this is extra here, foundation. You don't need any surface finishes. Then you have the construction of the arc itself. Okay, so some temporary support is required for the arc because it's a curve. Okay, so you have to support it from all the sides. Not the formwork only will not do the job. Then you have the reinforcement, pouring and curing, and then you will whatever false supports you have established, you will remove them. Okay, then you have the finishing and the aesthetics, surface treatment, painting, any decorative elements, any lighting. Okay, if they want any artistic designs or something, okay, you can see these things are optional. Then you go for landscaping and final touches. Landscaping is what you do around the building, around the structure. Okay, the plantation and the grass and these things. Signage, plaques. Remember, it's a entrance of the city, so there could be something for people to guide them and to know about this particular structure and so on and so forth. Anything decorative, okay, clean up and hand over. So this is the work breakdown structure, and if you know the type of structure you have, you can get to most of these elements. At least the main elements, I believe, you can get to them very easily without any problem. Just you may miss some items which are very specific. Okay, and this is not a big issue. Okay, so if you are doing it for your projects, then this is the case. If you cover all the main elements, that's fine. Okay, so this is the breakdown for the optional cost, the lighting system, the engravings, the decorative items. Okay, so these are based on lump sum basis, and they are depending upon what you are taking, and they are, even if you are doing it in real construction projects, most of these items are very flexible, and they are on these bases. They're like you just give the subcontract to a particular guy, specialist, who will say, I will do all this thing according to your requirement and this much. Okay, they do this for parties and functions as well in the same way. They will not say, okay, I will put lightings with 10-meter wire, so I will take this much. No, they say, okay, this is the hall, this is the design you want, I will take this much. Okay, so the same thing happens in the decorative work for the construction projects as well. Okay, so design and engineering, 50,000 cost. If you have any additional item, optional item, then you can see it's the cost for the whole thing. Okay, it's the cost for the whole work. So design will be ready in 50,000. Okay, you need something extra, 60,000, but it's the cost of the whole thing. Mobilization and site preparation, again, for the whole site. The site of this size, I will take this much. So it's assembly cost. Then foundation works, you have the size of the foundation. Okay, so you can calculate that for this much formwork and for this much concreting per cubic meter. Okay, how much cost will be taken. Okay, so now just a recap. If I am calculating the cost of the formwork, what are the units? The cost per what? I will calculate the cost per unit item for the formwork. So what will the units? Cost per so BD or dollars per what? Yeah, anyone? Yeah, it's per unit area. Okay, so nice. and for concrete it's per cubic meters and so on and so forth. Same thing with the arch as well. Okay, so you have the formwork, you have the concrete, and you have the steel. Okay, for steel it is per unit tons. Okay, then finishing aesthetics, we are talking about finishing the surface, plaster, paint, these types of finishes. So you know it's a, again, per square meters or per square area. Landscaping, signage, okay, again, total. Quality control and testing, okay, again, assembly cost method, or because you are not producing anything. Quality control or testing, you will not produce anything, right? So in the design you are giving me the design, right? In the site mobilization you will give me a clear site. So quality control is a process. Quality control is a process. So in the end you will say, okay, I did the process for the whole project. So that's why it's function based, but the concept is same. This is the size of the project, how much cost you will take, so you will give me the total cost. Okay, contingency, 10 to 15%. Empirical cost, empirical parametric cost. What was the meaning of that? We covered three approaches. Assembly was total, unit cost is per unit, and what is the meaning of empirical? Empirical parametric. How do we calculate the last one? So I just went through it now when I started the class. Anybody remembers? What did I say? How do we calculate empirical parametric cost? Anyone has any idea? No one? I guess I made a mistake when I mentioned the exam at the start. Huh? Everybody went into trauma. This is unit rate method. Or okay, how do we get the unit rate for empirical parametric? How do we get the unit rate in empirical parametric? What is the difference between this one and the unit cost? We are using unit rate there as well. Estimated from where? The estimation is the main difference between the unit cost method and the parametric cost method. So from where do we estimate the total cost of what? Total cost of what? So now you are trying to guess it from the name, huh? Because it's parametric or graph or something. I hope so. Anyways, the cost is from the previous projects. The cost is from the previous projects. Okay, so this is the difference between the unit cost method and the parametric cost method. The unit cost method, you are directly calculating the cost from this project. Okay, so when I was calculating the cost of the foundation, I took the unit cost of the items of this project. Okay, when I'm doing here, what I'm doing here is I looked at the past projects. In the past projects, my contingency, the money I spent extra because of unforeseen risks was this much, and this was the size of the project. So I take contingency cost upon the size of the project. This will give me unit rate for contingency, but it's not from this project, it's from the past projects. So then I say, okay, the past project was 1,000 square meter. This one is 2,000 square meters. So I will double the cost, and this double the cost will be between 10 to 15%. Okay, so the main difference between this one, empirical parametric, and the unit cost method is which project you are referring to for calculating the unit rate. Okay, the unit cost method uses the current unit rates for the items which are in this particular project. The empirical parametric looks at the past project to calculate the unit rate. Okay, so it's not really market based, it's basically experience based. Anyways, so the total cost will be this. The contractor will add the contingency and the profit and blah blah blah. So this will be this much. Okay, since the contractor is giving it, the total will be called as a bid based estimate. Okay, so in these numbers, sorry for that. Okay, so the actual cost is this much, 600,000 is the actual cost. Okay, if you add 20% of the profit margin, it becomes this much. Okay, if you are adding the extra items, the extra items are will make the cost up to 800,000. And if you add the 20% to 800,000, you will have this much cost. Okay, and if you do full customization and add everything, then the 20% added will be 1.2 million. Okay, so this is how much the changes can happen with the extra items. Okay, and obviously what if you are the contractor, let's say. Okay, if you are the contractor, which option would you go for? Option 1, 2 or 3, if you are the contractor. You will go with no extra or some extra cost, or you will go with full extra cost here, full elements. Which one would you go for as a contractor? Option 1, 2 or 3. Yes, anyone? Which option is good for the contractor? Option 1, 2 or 3. Okay, since you are not very keen on answering, you can do this poll. Which option you will go for? So most of you are saying 2. What about the remaining 18 people? Oh, sorry, 14 people. That's it. Okay. So can the people who are saying option 2, can somebody give me a reason from these 13 people? Why should I go for option 2? Why not 1 or 3? From these 13 people who opted for option 2, what did you have in your mind when you are saying option 2? Yeah, anyone? What about the others? Anybody who selected any option, would they like to give me a reason for that? Or you just selected at random? Anybody has any reason for the option which they selected? That's correct. Yeah, if even if you keep the same percentage, the amount of profit increases. So here the profit is 200,000, here the profit is 160,000, here the profit is 120,000. So as the amount of work is increasing, the profit also increases. But the majority of you said we will go for option 2. Okay, I believe even from the contractor's perspective, it will be a smart choice. Okay, option 2, even from the contractor's perspective, could be a smart choice. Why? Because when you are going for a full customized project, okay, you are also increasing the expectation of the client. You are increasing the expectation and requirements of the client. Okay, so higher the service, higher the expectation is. Okay, so you may be targeting more profit, but at the same time, you are also giving a chance to the client that he can be unhappy with you in more than one ways. Okay, so this is a risk which you should think about when you are selecting these options. Okay, so yes, some extra material here. I believe this is a link. If you click on it, it will take you to a particular website from where you can get more information about these things. Okay, so moving on. We were doing 11, 12, right? Yeah. Okay. Now we move on to another important part of construction projects, and this is getting a lot of attention in the modern construction projects. The old construction projects did not used to have so much attention on this element. Okay, Why? Because people were doing work manually, and the technology was not rapidly changing. The market situation was not so volatile. Okay, so there were a lot of factors which were stable. Okay, so obviously in a stable environment, the risk factor is very low. In a stable environment, the risk factor is very low. So, but if you have something like this, then the risk factor increases. Okay, when technology is so much changing and the world around you is so much changing, and again the client expectation is something which you have to look for. Okay, the client who is working or who is owning a project now has much more information at his or her disposal than what the old clients used to have. So even if you are constructing your first house, you can go to these online resources, you can go to videos where they will show you the whole procedure of the construction of a villa from start to end, the time, what they call time lag video or something. Maybe Hassan would have a better idea about it. Or Hassan could make a video for us for showing the whole process, right? But I highly doubt if he will do it. Anyways, so but the point is that you have visual representations, you have documents available, and you have now your own personal assistant in the form of these AI tools. So this is a major issue when it comes to construction projects, because now the client expectation is much higher, and he thinks or she thinks that they have more information about the project as well. Okay, and again then you have the market situation, which is much more volatile now. And one of the reasons of market volatility is you have heard about this term earlier in a good way. Okay, but I will tell you what is the problem. Okay, you have heard this term earlier, globalization, right? Okay, so everything is globalized. Okay, anything happening in one part of the world affects the other parts of the world. Normally we think it is a good phenomena for us. In many ways it is a good phenomena, but in many ways it is not so good. Okay, for example, take the example of US, let's say. Now US has outsourced a lot of work to industries in China and India and other countries because of the cost, obviously. This is part of globalization, outsourcing of the work to other countries. But that also means that US industry, is depending upon the stability and the conditions of other countries. Okay, so that increases the risk. So I may have been doing a project in USA, okay, or any of these countries, and nothing has happened in US or that particular country, but something has happened thousands of miles away in another country, but that is directly affecting you. So this is the effect of globalization on risks, and obviously this affects construction work as well. Anyways, moving on. So what is a risk? We have the definition which is given by the textbook of project management book of knowledge, which describe risk as an uncertain event or condition that if it occurs will have a positive or negative effect on one of the project objectives. Okay, so there are conditions which may not affect the project objectives. First thing is, risk is uncertain. Risk is something which is uncertain. Second important thing is, it is something which is uncertain and that can affect the project. So if you don't fulfill any of these conditions, then you will not call it a risk. Okay, you will not call it a risk. So for example, if you have if you are doing let's say concreting, open concreting, okay, So and you have chances of rain, so that's a risk, right? Okay, can I give you another example where, so let's say, uh, what example can I give you? Yeah, so let's say you are working on a design project. You are a consultant. You're working on design project, and you are using a software which has subscription. Okay, and the subscription ends at the year, and when the new year starts, you have to resubscribe it. Okay, so would you, obviously it is affecting your project. Okay, but is it a risk or not? Yes. So it is fulfilling one of the conditions that it does affect the project. Okay, but can we call it a risk or not? Yes, what about the others? You want to call it a risk or not? If I'm going to resubscribe a new software, is it supposed to be called a risk or not? Go ahead, give me your opinion. Yes, hurry up. Is resubscription of a software risk or not? You don't need to think so much, right? What about the other 17 people? Go ahead. By the way, I can like actually see who is answering and not answering. So I usually don't do this, but if I want, I can have a look. And just we were discussing the effect of globalization. Okay, I saw a news that a signal disruption in India has caused some problems here with the obviously the people who are using those networks. Okay, and so on and so forth. Anyway, so most of you are saying it's a risk. Resubscription of a design software is a risk. Okay, and those most of the people are wrong. Okay, resubscription of a software is not something uncertain. Yes, it is not a risk by definition. Yes. Okay, so resubscription now you don't need to go back. Okay, you don't need to go back, it's done. Okay, yeah, so a risk should be something uncertain. Okay, for the resubscription of the project, it is not uncertain. Okay, I know the exact date at which the software will end, and I know when to resubscribe it, so it's not something uncertain. Okay, uh, yeah, but the resubscription does not depend upon whether he has work or not. Okay, whether he has work or not, it does not depend upon whether he has work or not. Okay, it depends upon whether the resubscription will happen or not. The resubscription will happen. Okay, so it's not uncertain. Okay, so for example, breaking down of an equipment. Okay, this is not uncertain. Oh, sorry, this is uncertain. A student may equipment may break down at any point. I don't know it. Okay, but it's not the same thing uh, But the point is you may decide whether you want to do it or not. Okay, you may decide whether you want to resubscribe or not, but the uh, resubscription happening of the resubscription is not uncertain. Okay, I hope you get this point. The happening of the resubscription is not uncertain. Falling of the rain is uncertain. Equipment breaking down is uncertain. Okay, but finishing the fuel of the equipment is not uncertain. I know this much is the mileage of the equipment, and after this much mileage I need I need to refill. So this is not uncertain. Okay, so this is the element I was emphasizing on. Okay, this is why I give this example. Okay, so when something is sure to happen at a particular time or after a particular incident like the refueling, then it is not a risk. Okay, you may say, okay, I'm not using the equipment, so I will refuel it, I will not refuel it. This is your decision. What you want to do is your decision. Okay, you may say that, okay, I use this software, now it is subscription is ending, I'll go for a new software, or I will develop my own software. Okay, so you may decide, I don't want to do the resubscription. This is your action. This is your action. This is not the risk. Risk is what is happening. What is happening? End of subscription. Is end of subscription uncertain? No. End of subscription is certain. That if you don't pay, software will end. So this is not uncertain. What you do in case of that event is your action. It's not part of the risk. Okay, so you cannot say maybe the contractor will do it, will not do it. This is not risk. This is his action. This is his decision. The risk is not related to a particular decision which somebody in the project is taking. Okay, and so on and so forth. Okay, I wanted to give you another example. Let's say, what example can I give you? Let's say you are working in a country which, for example, you are working in Bahrain. Let's say, okay, Bahrain has its own, aluminum factory. Okay, so let's say, and there's another aluminum factory which is in China. Okay, and that factory goes on a strike. Okay, and your project is, or there's a chance that that factory can go on a strike. Let's say there are problems happening in China, and there's a chance that the supply from China may stop. But you are already using the aluminum from Bahrain. Okay, so this closing of the factory in China, is it a risk for your project? What do you say? Price increase can be uncertain. Yes, that's a risk. Increase in price can be a risk. Yes. Just before I rephrase the question, yes, the example I gave you for the resubscription, the project depends upon the software. Yes. So this condition is met. But the other condition is it uncertain that the subscription will end? So it is not uncertain. So it's not a risk. For a risk, both conditions should meet. Now the other question which I gave you is, I'll just write the question. Okay, it's a long question. Okay, if you are using aluminium from Alba, there's a chance that the supply of aluminium from China may be stopped. Is it a risk for your project? So do I consider this condition, the closing of the factories in China? Okay, closing of the factories in China, do I consider this as a risk for my project? Yes or no? Okay, yeah, one saying yes and the other one saying it wouldn't be a risk. I need a tiebreaker. Anybody else? One person is saying no, one person is saying yes. I need a tiebreaker here. Somebody? Is it a risk for your project where you're using aluminium from Elba? Okay, the tiebreaker did not do very well here, huh? No, it's not a risk. For your project, it's not a risk. Okay, because you are not using the aluminium which is coming from China. If you're using the aluminium from China, that would be a risk for your project. Okay, if you're using the aluminium from Elba, then the chance of Elba closing will be a risk for your project. Okay, so I gave you three examples here, right? I gave you three examples. One was breaking down of the equipment. It's uncertain and it is related to your project. It's a risk. The second example was resubscription of the software or the ending of subscription of the software. It's not a risk because it's not uncertain. It is for your project, but it's not uncertain. Third example, the closing of the factory in China from where you are not dealing with any material. So it is uncertain, but it's not related to your project. Okay. So the conclusion is for a risk to be considered, you must fulfill both conditions. Both conditions include it should be related to your project and should be something uncertain. Okay, if it is not affecting your project, then it's not a risk. Okay, risk can be positive or negative as you can see here. Okay, risk can be positive or negative. Increase in price, negative. Closing down of something, negative. Equipment breaking down, negative. Okay, or risk can be positive as well in some cases. Okay, let's say you are working on a project where you have to test the flow of water in the end. Okay, and on that day there is rain when you have to test the flow of water. So there is natural water now and you can check it without spending your consuming your own water supply here. Okay, so that's like a positive risk for that day and for that project. Okay, and so on. Or for example, you have two or three sites and you need more equipment or more labor on one site. Okay, and suddenly the other site closes, so now you have more equipment, more labor available. So that's a negative risk for site 1, but suppose something positive for site 2. Now you have more things to consider for the other one. Okay, current situation for us, you are sitting at home. Okay, I have to ask you, please reply to me. Please reply to me. Say yes or no. So for you guys, it is positive, right? You have online exams, uh, where you can go and you know ask your AI friend or real friend. Okay, I am at home, but I have to beg you to give me the answers, right? Okay, so not so good for my teaching, right? I'm saying in terms of my teaching, like I don't like talking to a screen, huh? Which you will always do. Like it's not like you are doing it now. Even in the physical classes, you have to beg for marks. So this thing has not changed. What has changed is now you can be in the class and sleep as well. You have taken this is your second course with me. I bet you cannot sleep in my class if I'm taking it physical, right? Okay, I know you don't want to sleep, but there are others who wanted to sleep and now they can do that. Okay, they will not even know what I'm doing. Okay, so yes, for you I believe it's positive. Okay, moving on. uh, the most important risk in the construction projects is mainly to the for the delay. Okay, most of the risks are related to the delay of the project. Okay, scope normally we can control it. The money, we have some additional amount which is uh, which is allocated for risks, 10%, 15%. Okay, so in most of the cases the risk can be within the amount you have allocated. Okay, but the problem happens mainly with the delay. Okay, we did a study many years ago, it was published as well, where we focused on the delay items. So the most important or the most recurring risks for the construction projects are related to the time. Okay, and this is also because, as we have seen in CPM and PERT networks, that one activity can affect the other. Okay, so something happens on a activity on a critical path, the whole project, all the activities after that will be affected. Okay, so it becomes very complicated. Okay, this interdependency is very complicated. Okay, so the risk can be in any stage of the project. Okay, from planning to completion, like any stage can be delayed. Okay, any stage can have or has some uncertainty, and that can have delays or some other losses or some other positive coming out of it. So a risk is a possibility of something bad happening most of the cases. When we say risk, what comes to our mind? Negative, right? Something bad. And it must be uncertain, and it has implications maybe for the whole project, or it could be for an activity of the project. Okay, and the effect should be something which you value. Okay, so let's say if because of something some risk or some condition, now I have like maybe uh, uh, maybe more heat or more temperature or something like this. Okay, so that is also a risk. Okay, because this is affecting health and it is affecting well-being of the workers. Okay, so if you look overall, you will not find any problem. Okay, everybody is working, no price increase, nothing closed. Okay, but in the same working conditions, now the change has happened. Okay, so earlier people were working at temperature of 30, 35. Now the temperature has increased because of something to more than 40. So this is also a risk, even if it does not close any activity, but it is affecting the workers. Okay, so risk may not be always affecting the cost or the time. Sometimes it affects the people working on it. Okay, so you have to consider that as well. Okay, don't just look at the material aspects, also look at the human aspects. Okay, this diagram shows you the value. Okay, you can see value on one aspect, and you can see uh, the increasing risk on the other hand. Okay, right hand side is the value, like how much money or how much uh, loss you can have if a risk happens, and what is the percentage of that happening. And on the x-axis you have the timeline. Okay, on the x-axis you have the timeline. So so on the right hand side you have the impact, on the left hand side you have the chance of happening. Okay, so impact and chance, and according to the timeline of the project. So at the initial stage, the impact of risk is very low because no activity is happening on the project is just in the initial phases. So the amount of money invested, amount of work done is almost none. So the impact is very low. Okay, so you are just thinking about it, you may have done some meetings, you may have prepared some sketches. Okay, so even if something has changed, you will redo it, it will not cost you that much. Okay, but because you are at the initial stage, there are more chances that something unforeseen can happen. As you go along the project, you are better aware of the site conditions, you are better aware of your team, and you are better aware of the methods and procedures and all these things. Okay, So at the initial stages, I told you in the last lecture, even the cost has more error in it, okay, or the cost is less accurate. Why? Because at the initial stage, I don't have the knowledge, full knowledge about the project, the site, the person, the team, the methods, the labor, the material. As you go along the project, your knowledge increases, so the chances of anything uncertain decreases. At the initial stages, you have not started the work, okay, so there are many things which are uncertain. So but as the uncertainty is decreasing, okay, the value is increasing. You can see the uncertainty decreasing. But if anything uncertain happens at this stage, it will have more impact because you already have invested more resources here. You have invested more time here. Okay. So the number of uncertain things are decreasing, but the loss because of that thing will increase. Okay. So if rain happens during planning stage, no loss, right? Okay. I'm just sitting in my office, no loss. If the same rain happens when I'm doing concreting for my site, the loss can be higher. The whole work can stop. Okay, I may have to pay for an extra amount. Okay, some equipments may get damaged. Okay, my concrete mix may get rejected. My material stored on the site can get rejected. Okay, so this will happen later. At the earlier stages, all these things, all these problems are not there. Okay, so so this is what they are showing here. Okay, here the unknowns are more, and here the on this stage it becomes more. So number of unknowns when they are the uncertainty. Okay, if the difference between the unknowns and the we want to, I may not be able to, but if you, okay, you understand this thing, right? You understand this thing. I don't, my mind is stuck. I don't know how to explain this thing. Okay, but the thing is, when you have less uncertainty and you have less impact, this is good for you. Okay, so somewhere here it's good for you. Okay, but you cannot control it. In the end, you have to go through all the phases. Okay, in the end, you have to go through all the phases. Okay, so what is showing is that if you have things which are unknown and uncertain, if they are favorable for you, you consider it as an opportunity, and if they are unfavorable for you, you consider it as a risk. Okay, so here they are giving a different name to positive risks. They are calling it an opportunity. So like we can have price increase, we can have a price decrease as well. Okay, like or we can have a new material which is much cheaper, or which can do a better job in the for your project. Okay, so this will be an opportunity. So they are playing with the normal perception that something bad is called risk and something good is called opportunity. These are management terms. But my point was, if you look at this diagram, you cannot control that I will only stay at this point. No, you have to go from the concept phase to the closing phase, and you have to endure whatever this thing presents. Okay, the highest value, you can see it's here. Okay, so whatever you have to deal with it. You have to deal with all the stages. Okay, so it's not like you are controlling anything. Okay, you are just dealing with the stages. You just deal with the stages. Okay, what is risk management? It's the art and science of identifying, analyzing, and responding to the risk throughout the life of the project. This is what I was saying. You have to respond to the risk. You cannot control it. There will always be risks at lower stage. At initial stage, the risk impact is lower, uncertainty is higher. It becomes opposite when you go along the project. So you have to control the risk according to this throughout the project. Okay, so risk management is a complete project activity. Okay, and you try to manage your risks throughout the project. But for managing the risk, you have to do three main items here. Okay, the first item is you identify the risk. Second item is you analyze the risk. Okay, if this thing happens, what can be the impacts in terms of time, in terms of cost, and so on and so forth. And the last thing is your response. If this thing happens, then what will I do? So if an equipment malfunctions, this equipment malfunction will affect what activity, how much money I will need to repair it, and who will repair it, and how much time it will take. Okay, this is your analysis. Identification of the risk is equipment malfunction. Analysis is how and what it will affect. And response is when it will happen eventually, what will you do? Okay, who will you call? How will the equipment be taken to the workshop, and so on and so forth. Okay, so these are the three main items in this activity, risk management activity. And you will try to do it and to meet the best the interest to best meet the interest of the project. Okay, so for example, take the example of equipment malfunction. If equipment malfunctions, you can rely on someone who will take it and who will repair it, or you can have someone who is dedicated on the project. He will remain on the project and he will look after all the equipments. If a minor repair is required, he can take care of it. Okay, so which of these options is in the best interest of the project? Okay, so then you have to look at which will save the most time at minimum cost, and so on and so forth. Okay, so you have to you may have different options for responding to the risk. Eventually you will do the one which is more beneficial for the project. So you will not send it to the workshop because the workshop belongs to your friend, so he will get more money and more business. Okay, if it is not good for the project, you will not do it. Okay, so the risk management is finding out the risk, knowing what it will do, and then deciding what you will do. So and this is done in advance. Okay, it's not like when the equipment malfunction happens I will think about it. No, risk management is part of the planning of the project. Okay, so I have a plan, I have these activities, I need this material, this equipment, this much labor, and then you identify the risks, and whatever risk you identify, you will do the whole process for it. Okay, what can happen, and if this happens, what can how it will affect the project, and then you decide your action in advance. Okay, so you are not waiting then when it will happen. No, your action is already in place. Okay, so equipment malfunction, the plan is already there. Now you know who to call, how to do it, and so on and so forth. Another thing which I want to highlight here is it's science and art both. Risk management is science and art both. Okay, science is something you can analyze, right? Science is something you can analyze. Art is something subjective. Okay, so subjective means what? Me and you may be looking at the same thing, but we can have different perspectives. Okay, just like tea, or just like a painting. Okay, or just like a song. Okay, I may like a song very much, and you may say that I don't like it at all. So this is because song is part of the art. So same thing happens in risk management. Two managers which are looking at the same project may consider one thing as a risk and may decide to do one action for it, and the other manager may not consider it as a risk, or even if he or she considers it as a risk, they may decide different action. Okay, so it's not totally about engineering. It also it is also affected by how the people are thinking. Okay, so risk management is both an art and a science, because it's not always about calculating things. It's also about your own judgment and opinion on perspective. Okay. So uh, the later points, as I already mentioned, that uh, you integrate risk management in your overall management plan. Okay. And you should do it proactively before the risk happens, and in the end your action should be the ones which will be best for meeting the project objectives. Okay. uh, so how do we integrate risk with other project management functions? Okay, so this diagram shows different project management functions. Okay. And for example, scope, you have to find out the expectation of the client, you have to do the feasibility study. Okay. So in the feasibility study you will consider the risks as well, and the expectations already mentioned. Okay. uh, Life cycle and environmental variables. Okay. uh, Extremely high temperature, extremely rough weather events. Okay. So you have to consider that when you are managing human resource, the availability and productivity of the human resource. I need more labor, but on that particular day somebody got sick, or there was something like COVID or something, so people are not available. Okay. Or the temperatures are very high, so their productivity is less. Okay. So here you can, I've just given you some examples, but you can have a look at this diagram, and you can see they have mentioned the points where the risk actually can happen during the project. Okay. So the boxes, outside boxes, are project management related functions. Okay. And these points are what can cause the risk. This one, for example, data accuracy, data exchange, data privacy issues. Okay. The data got leaked and so on. So these are all uh, risks which are attached with the project. Okay, some of the risk I already talked about. Delays, most common risks are related to delay. Okay. The delays can be general delays. Okay. Maybe because of lack in planning. So when you are planning for the project activities, you do not do it properly. Okay, I'm going over time, so I will stop here. So we will continue from here next time.